Hi all, welcome to my YouTube channel Know About Embedded System. In this video, I'm going to explain you or I'm going to show you how to create a project for LPC1768 microcontroller using Keil software. Okay, so if you have not subscribed my channel, so please subscribe my channel and motivate us to create videos like this. So without further delay, let us start today's video, how to create a project for your Keil software. So guys, in the previous video, we have explained you what is the architectural view of LPC1768 microcontroller. So today I'll show you how to create a project for LPC1768 microcontroller and how it looks like in a debug window. And later we will go to the programming exercises. So without further delay, let us start the video. So for this LPC1768 microcontroller, the best software which is available for practicing is Keil. The Keil µVision 4 is the software which is available freely only for education purpose, not for commercial purpose. So this Keil µVision, you can directly go to the Keil website and you can provide your email IDs and some other basic informations and you can download it for your practicing purpose. Okay, so when you open the Keil software, it looks like this. I'm using Keil µVision 4 and even different versions available. You can download µVision 4 and 5. So any one is enough for practicing our LPC1768 microcontroller programming. So this is how it looks like. In detailed video, I have already one video detailed how to create a project and how to work with. So you can watch that video as well. But now I'm concentrating only on LPC1768 microcontroller. So to do that, so now this is your µVision 4 and here you can see this is a file and this is a project. You can just click on the project and click on create new project. There are different options they have given here. You can see the project and you can see the open project, close project, and many operations are there. But whenever you're doing first time, you need to go to new project. You can just click on this new project and wherever you are doing project or wherever you want to do the programming, you can just create one folder, common folder. Okay, let us keep it on desktop. And I'll create one folder here, LPC 1768. You can just create one common folder. Here you can create one name. So the name should be, you can give any name, but make sure there should not be any extension, because when you create a project, automatically the extension will be popped up here. You can see I'm giving a demo and you can see the save as project file. So automatically the extension and project and the extension type and what type of file it is, it will be taken automatically. Just click on save here. And important thing lies here. You have to select a proper vendor and which microcontroller you're using. So already in the theory part, I have explained you this LPC1768 microcontroller developed, designed and developed by NXP, founded by Philips. You just click on that. He is the vendor, or this company is the vendor, founded by Philips, and then expand here. And just slowly you can scroll down. You will get somewhere 1768. Here you can see 1768. So this is my microcontroller, and in the description part you can see the whatever we have explained, everything is described here in a short. What processor it is using? It is using Cortex-M3 processor it is using, and operating speed is up to 100 megahertz, 12 kilobyte of flash, and so on. Many description, many information is given. So if you want, you can go through that. And now just you can click on OK. And it is asking copy NXP 17XX startup code. So what is startup code? I'll explain in upcoming video later. It is just asking for copying the startup code. Click on S. Yeah. So here you can see the project has been successfully created, and here this is your startup file. You can in the start what is startup in detail I'll explain in any one of the video in upcoming videos. So about this we are not concerned right now. So this is my project, and I will take a new file here. Just you can go to file and take a new file, and you can save it as test1. And now what you have to do is .c, how to give extension. The file, make sure wherever your project is created, in the same folder your .c file should be there. So here in the desktop, I have created 1768, and inside that I'm going to create one .c file here, test1.c. Click on OK. Yes, and then I'm going to write a simple code here. I'll increase the font here a little bit. Go to .c and I will increase to 16. Click on OK. Just I need to increase the font size. So now this is how. Okay. Yeah, so now let us write a sample code here. I'm going to include my header file here. The header file for this is lpc17xx.h. This is my header file for your LPC1768 microcontroller, and then you can write a sample code here like this and save it. So this is my sample code, and so this .c code should be added to the source group. I'll just double click on this source group, click on this, and it will directly fetch you to the same folder where you have saved your .c file. Or else you need to know where your .c file is saved. So I have saved in the desktop, and then inside that LPC1768 folder, and then my test1.c. Okay, just you can double click on this and you can see the test1.c file has been included into the source group. So if you do not include your .c file, it will throw an error. Okay, so now what I did is I just added my .c file here. Do the compilation. Just this is the first step of compilation. You can see it says the 0 errors and 0 warning, and then click on build targets. So the second option what you're seeing, this is called build target, and third option is called as rebuild target. So these three options we have to use in order to compile and to generate executable files for your particular microcontroller. Okay, so when I expand this, now you can see when I expand this test1.c file, the mandatory files which are required to compile your code will be automatically added. You can see this is my header file, and this is my Cortex-M3 header file, and this is a standard input output, and then some system.h. So these things I'll be explaining in the next videos. So my scope is not to explain all this, just my scope only to create a project and show how in debug window how it looks like. So once it is done, I'll go to debug option here, click on this debug, and it says that evaluation mode, and it is running in the size limit of 32 kilo. So what do you mean by this? This is saying that the program size of this file should not exceed more than 32 kilobyte. So no problem, since we're only the practicing purpose or educational purpose we're using, so not an issue. Just click on OK here. Yes, so this is your debug window. I don't have anything to show here, just I will show you what are the different contents which are present in the debug window. So you can see here we have register set R0 to R15. So what is this R0, R1, R2? These are all the registers which are available in our ARM Cortex-M3 processor. And if you want to know about this, I have already one more video based on ARM architecture. You can just watch that video as well. In that I have explained you what are the different registers available in the ARM processor. Okay, then this is your status register. The PSR stands for program status register. In this, different flags are there, and the different interrupt service definitions or interrupt service routine numbers also defined here. So this is N stands for negative, Z stands for 0, C stands for carry, V stands for overflow, Q is a static timer, T stands for thumb mode, and the interrupt continue, and then we have ISR. So like all these things I have already explained in the previous video about ARM, so you can just watch that video as well. Okay, and then that's it for this. So remaining things I'll explain later, which will be addressed later point of time. Now coming back to the tool here, and I wanted to show one important things, peripherals. Here you can see there are many peripherals they have shown here, and I'll start one by one here. Core peripherals are there. In this core peripherals, NVAC, nested vector interrupt controller, system control block, static timer, all these will be coming under core peripherals, nothing but processor related peripherals. These are all. What all this I'll be explaining in upcoming videos when we start with one by one. Then we have system block. Here in the system block we have external interrupt, then system control and other infos are there. And then if you want to generate different clocks, so I have already explained in one more video, we can generate a different clocks with a different value. High frequency clock we can generate and low frequency and so on. So based on these configurations, clock source selection, clock dividers, and phase lock loop 0, phase lock loop 1, all based on the configuring these things, we can generate a different frequencies for your microprocessor which is running inside the microcontroller. So that we will discuss later. And this is related to flash memory, and this is related to pin connect block. So from this pin connect block we can configure different pins in a different configurations. Like each pin can be configured in a different operating mode, so that can be configured in this pin connect block. How to do that we will see later in the upcoming videos. Then GPIO fast interface. So here this I'll be taking in the next video. What are the ports available? So total ports available in this GPIO, in this microcontroller, there are totally 5 ports are there. They have given the names port 0, port 1, port 2, port 3 and port 4. How many pins available? I'll just show you how many pins available in this. So port 0, you can see all 32 pins available, and then port 1 again 32, and then port 2 here only you can see the tick mark is there, no? Only these many pins available. And then so now GPIO 0, 1, then GPIO 3. Here you can see in GPIO 3 only 2 pins available, and then GPIO 4 only 2 pins available. So these many port pins available for programming different GPIO peripherals. Okay, so I'll be explaining detail later. So as of now, not required to understand in detail just. Okay, so now I'll just close all these things. So this is, and then we have UART. We have totally 4 UARTs available here. Then we have CAN, 2 CAN controllers available, CAN 1 and CAN 2, SPI, SSP, I2C. We have 3 I2C interfaces. We have 4 timers. And then we have pulse width modulation, we have RTC, we have watchdog timer, we have ADC, and then we have DAC. So these many peripherals are available in this microcontroller. Okay, so each block or each peripherals I'll be taking in each video, and we will discuss and we will develop the coding for these peripherals. Okay, so this is what I just wanted to show you in this video, and then I'll come up with one more video and how to do the programming for the 32-bit microcontroller, especially 176-bit microcontroller. Okay, so now with this I just want to end a video here, and I'll come up with the next video. And if you have not subscribed my channel, please do subscribe, and let us meet again.